By the request of my students, I had done some video lectures on the series of video lectures on quantum mechanics. Now, after the completion of the lectures on quantum mechanics, today onwards, I shall start to do the video clip shooting on the thermodynamics of electrochemical cells. And today, just in lecture 1, give you the introduction. The cells, all we know, for any spontaneous process, whether it is physical or chemical, the free energy of the system will decrease when conducted at a constant temperature and pressure. And this free energy sometimes also called the chemical energy. And the free energy, the decrease in free energy is being converted into the electrical energy by a device which is called the galvanic cells. And in another type of cells are there which is called the electrolytic cells, in which the external electrical energy have been applied to do the chemical reactions at these electrodes, and these reactions are non-spontaneous, and these non-spontaneous reactions are made to spontaneous by the applications of this electrical energy from outside source from a battery. Today, and you know, these cells are consisting of the two electrodes. These are the electronic conductor, and the electronic conductor are dipped in partially into the electrolytic solutions. And it is a very novel device, very useful device made by the scientist. The chemical reactions could be used to produce this electrical energy. And the one example I have given here in the upper side of this board, and this one is the galvanic cell, and this is very favorite cell. This is called the Galvanic cell, and here the reaction is zinc plus copper ion give you the zinc ion plus copper, and this reaction is spontaneous. And when the reaction occurs spontaneous, the free energy of this system is decreased. This free energy, or we can say the chemical energy, is converted into the electrical energy by this process. Suppose very simple, here is one container, here is another container. In this case, the zinc sulfate solution have been taken, and here copper sulfate solutions have been taken, and zinc rod is partially dipped into the zinc sulfate solutions, in copper metal plate is partially dipped into the copper sulfate solution. If we do these reactions in a beaker, then the reaction zinc will donate the 2 electrons to the copper ion. Here also each zinc atom will donate 2 electrons to this copper, and this transfer of electrons, whenever we are doing these reactions in a beaker, this transfer of electrons becomes random, and no fruitful or useful work we can receive whenever it is done in a beaker. But this same reactions is done in a device, in a mechanism, which will give you the electrical energy by these fashions. Here zinc and copper, zinc zinc and zinc metal and copper and solutions, they are separated by the same fashions. Zinc is dissolved in zinc sulfate solutions, zinc is dipped into a zinc sulfate solution, copper dipped into a copper sulfate solutions, and the reaction occurs like this. In the left hand side, zinc, some zinc atoms converting into zinc ion plus two electrons, and these electrons are dumped into this zinc plate. Here copper, zinc is more electropositive than copper, and in this case, this copper ion, small copper ions from this small amount of this copper ions from this copper sulfate solutions takes up this electron from this copper metal plate and forming this copper atom. This copper atom is deposited on the surface of this copper metal plate. So here this is the reduction, this is the oxidation, and you see here there is an excess of electrons or surplus of electrons, here deficit of electrons, this is negative electrode, this is positive electrode. Negative electrode is called anode here, and positive electrode is the cathode. And whenever if we connect these two electrodes by a metallic wire, and if we keep one bulb, then bulb will glow. Means electron is moving from this zinc plate to this copper plate, and this bulb is glowing. If we keep here a bell, then bell will ring. If we keep a digital clock, this digital clock will also run. Very simple arrangement. Here these two solutions are separated by means of a porous barrier. And this is the Daniel cell, galvanic cell, and this reaction which is occurring spontaneously, its energy is converted into electrical energy. By the other side of this other type of this cell called the electrolytic cell, and this one is the galvanic cell. This one is the galvanic cell. Galvanic cell, and this electrolytic cell, suppose here acidified water is taken, and water is dissociating as hydrogen ion, hydroxyl ion, hydrogen ion. So many hydrogen ions, hydroxyl ions are there in the solution in this acidified water. Here two platinum electrodes are dipped into the solutions, and these electrodes, you see this electrode, this is the battery, this is the source of this electrical energy. This we can connect this one, this is the source of this electron is coming here and here, and this one is the negative electrode means there is an excess of electrons. And this platinum plate is also negatively charged, and the hydrogen ions are positively charged. They will be attracted by the Coulombic force of attraction, and the hydrogen ions come to this metal plate, platinum plate, and takes up this electron. Two hydrogen ion will take two electrons and forming one hydrogen molecule, gas molecules, and it will evolve from these solutions. Again two electrons are depleted here. In this case, this one is positively charged. So this platinum plate is also positively charged. Majorly these two hydroxyl ions also go to this positive plate of this platinum, and these two hydroxyl ions are forming this water, half oxygen and plus two electrons, and this oxygen again removed, and this one is the oxidation. This one is the reduction reactions. Sum of the two total reactions, you can see the water plus water will give you the hydrogen gas, and here the oxygen plus half oxygen gas. This reaction is not spontaneous, but this reaction is made to spontaneous by the applications of this electrical energy obtained from this Daniel shell. So one thing is very confusing. You can say here the negative electrode is anode. Here positive electrode is cathode. But in this electrolytic cell, the negative electrode is cathode. Here it is anode. But here the positive electrode is anode, but here positive electrode is cathode. Here the cations are coming to this electrode, so it is the cathode. Anions are coming to this electrode, so this is anode. This confusion of the terms anode and cathode could be cleared if we consider the nature of this reaction. This is oxidation reactions, and in anode oxidation reactions is occurring. Here also this is the anode, oxidation reaction is occurring. Here the cathode, it is reduction. Here it is also reduction. So electron generated here coming to this way, electron generating, coming and plating and coming to this plate, and the electrons cannot go through these solutions. The current or the electricity are carried in the solutions by the ions, and this is why the ions are called the current carrier. So these ions here, two electrons are depleted by these two hydrogen ions, and here the two hydroxyl ions gives two electrons, as if the two electrons are coming from this place to this cathode to anode, and here the electron is moving, here electron is moving and coming to this plate and provide these electrons to this copper ions to form this copper atom. So this is the total circuit. Total circuit is completed, and you see, we shall concentrate our discussions only to the electrolytic to the galvanic cells, and electrolytic cells will be discussed somewhere else. So this is the actually our target of this discussion, this galvanic cells, and one example of this galvanic cell is the Daniel cell. So this whenever we are writing these cells, it is not very easy to draw this picture like this one. In short, we can write the cell representation like this one: the zinc, and one single boundary, and here it is zinc sulfate, and suppose its concentration is A1, and activity, and this double vertical line, here it is copper sulfate, and it's within the bracket, it is copper sulfate activity A2, and this single line, and this is copper. So this whole picture could be represented in a very simple way like this one. And in the left hand side is always negative. Negative means anode, and here it is right hand side is always a positive electrode, and it is the cathode. This is the convention. And the single vertical line is the phase boundary between the solid and this liquid. Solid and liquid. This is the phase boundaries. And double vertical line represents either this porous plug or insertions of the salt bridge. Salt bridge we can also insert here, and this double line means the two solutions are preventing from the free mixing. And here also copper sulfate, within the bracket we write these activities. It is better to write the activities as you have seen for these electrolytic solutions. The concentrations, use of the concentration is not better. Rather, the activities are the better term to use whenever the solutions are the electrolytic one. And this A1 is the activity of this zinc sulfate, A2 is the activity of this copper sulfate, and this copper, and this is the, in short, writing the cell representation of this Daniel 1. So again, we can also discuss several factors here. The spontaneous reactions will giving you this electrical energy. These cells, these galvanic cells are of two types. Galvanic cells are of two types. One is reversible, one is reversible cells, and another is irreversible, and another is irreversible. It could be divided into two types, reversible cells. So to consider the reversible, whether the cell is reversible or irreversible, we shall have to apply the thermodynamics. In case of thermodynamics, we know when the opposing force and the driving force becomes infinitesimally small, this process is called the reversible process, and whenever the reversible process occurs in this cell, it is called the reversible cell. Whenever if we apply the opposing forces slightly infinitesimally greater than the opposing forces, then it is possible to restore the initial state of these cells, and these are the criteria for these reversible cells. When these two criteria are not being maintained, it is called the irreversible cells. We can also study. We can also see whether this one is reversible or irreversible. Say for now I shall show some criteria for a cell to be a reversible one. And this is the very unique cell, and this cell is perfectly reversible. And here the HCl solutions, and left hand side, which is anode, and platinum plate is dipped, and on the surface of this platinum, this hydrogen gas at 1 atmosphere have been bubbled up. And the right hand side, the silver metal plate is dipped into the solutions, and the silver is coated with this solid silver chloride. This is the cathode and positive electrode. So the reaction here, the left hand side always oxidation, right hand side is always reduction occurs, and oxidation in case of a hydrogen, half of hydrogen gas molecule converted into hydrogen ion plus electron, and here the silver chloride takes up this electron, giving you the silver plus Cl minus, this reduction. So net reaction is this one. Half H2 gas plus silver chloride solid and arrow silver solid plus HCl. Since H ion and chloride ion coming from the same solution, so instead of hydrogen ion and chloride ion, we can write this HCl. HCl here it is in aqueous solutions. So this cell having no liquid junction, since only one liquid is there, one electrolyte is there, electrolyte solution is there, so no question of this liquid junction is totally absent. Here the potential of this cell or EMF of this cell, suppose E, and this cell is set with a battery. This one is the battery of some external battery which is just arranged in opposition to this cell. Here it is negative electrode and negatively charged. Here also negatively charged. This one is the negatively charged. This one is the positively charged. Means these two cells are, this cell and battery, these two are arranged in opposition. And if the suppose at this point, this is the null point. At this point, whenever this jockey is at this point, no reaction occurs. And in this case, E equal to E dash. Whenever E dash the battery potential of this battery could be varied by means of rheostat, and whenever this E1 is equal to E1 E dash equal to E, there will be no reaction occurs. But whenever this cell, suppose E is greater than E dash, means this jockey is kept slightly infinitesimally small distance at this left. Then potential difference or this EMF of this battery becomes less than this cell potential, and in this case this reaction occurs. But whenever if we keep this jockey from this point to this point, then the potential difference, which is the E dash is greater than E. In this case, the cell will act as the electrolytic cell, and this reaction is totally reversed. Means silver S plus HCl aqueous, and giving you this half hydrogen gas plus silver chloride solid. Means this cell reaction is totally reversed, and this is non-spontaneous and this is spontaneous. This is non-spontaneous reaction. Non-spontaneous reaction is made spontaneous by this battery, when battery potential is greater than the cell potential. If we allow to pass the same amount of this electricity, then in both the cases the cell will come to its initial positions or the restored positions. But another type of cells I may consider these irreversibles, and you know we shall always discuss these reversible cells. Why? Means all the thermodynamic principles, reversible thermodynamic principles, would be applied only to these reversible cells, and this is why we shall throughout discuss these reversible cells. But one example I can also give this irreversible cells. And for the irreversible cell, these conditions are not being maintained. And say one example is given here. Suppose here is the dilute sulfuric acid is taken as the electrolyte, and here is the zinc plate is given, and here is the copper. When the this reaction, these reactions, whenever you connect this one, say suppose some means of electrical wire, then zinc plus sulfuric acid, or if we place this cell in this way, in this place, if we keep this cell in this place, then the whenever E equal to E dash, still the reaction will occur. Still the reaction will occur whether it is kept open or connected to a battery, and these two whenever equal, this reaction will go continue. And if when E is greater than E dash, the cell reaction becomes a zinc plus sulfuric acid, the sulfuric acid, and giving you the zinc sulfate, which is spontaneous, plus H2, plus H2 gas removed. But when E is less than E dash, whether this galvanic cell is acted as the electrolytic cell, then in this case the battery is having more potential than this cell potential. In this case, this reaction is not reversed. It will give you copper plus sulfuric acid, non-spontaneous reactions, giving you the copper sulfate, and plus again hydrogen gas, and this one removed. So this reaction is not reversed. So this is why this type of cell is called the irreversible cells. If we keep this cell open, then also this reaction will continue. This is one of the spontaneous reactions. So this is in a nutshell reversible cells and irreversible cells. We shall not discuss any irreversible cells. We shall restrict our discussions only to this reversible cells, which is very important to determine the thermodynamic properties of these solutions. So these cells are not actually used for commercial purposes. They are of theoretical interest. Several physical properties like activity coefficient and the free energy change, entropy change, and the enthalpy change, and dissociation of this weak acid, solubility product, and so many properties, physical properties could be determined through this reversible cells. So not only that, the potentiometric titration, one type of titrations which is called the potentiometric titrations, would also be done by the use of these reversible cells. Actually, we shall this is the introductory lectures, and in my next class I shall show you how this cell potential could be determined experimentally without drawing this current from this shells, so that it will act as the reversible one. So actually the single property, the EMF of these cells, we shall determine by means of potentiometer, and we shall connect the EMF of these cells with several physical properties of this electrolytic solutions, and could be determined by measuring this EMF of these cells. And this lecture is not only useful or helpful for these chemistry honors students, but also it will be equally helpful to these iit-jee and neet aspirants, and also in other national and international international competitive examinations. So this is the all about this introduction. In my next class, I shall discuss how this EMF of these solutions or the potential cell potential could be determined experimentally by means of potentiometer. Thank you all who are watching this video. I think you all will respond to the same extent as you have done in case of my series of lectures of quantum mechanics. And thank you all again. If you like this video, then subscribe, and then I shall get more inspiration to do more video classes in different lectures, different subjects also. Thank you all.